exercise 14B, parts 1 to 3. Let's get that on the screen so you can see it. Oops. Right, so this is all about, for particular angles, determining the values of sine t and cos t. Now, referring back to the diagram in the book, I'll just bring that down here. Big up. The relationship between sine and cosine is such that the y value here is the sine of the angle in the unit circle, and the x value here is cosine of the angle. Now in this example they've said that alright, so we're given angles, but notice here that because you've got pi's in there, that they're dealing in radians, but that shouldn't make too much difference at the beginning. So one other point to note is that in terms of radians, you're used to circle having 360 degrees. With radians, if you go all the way around, it's 2 pi radians. So, and also another little handy tip is then you're used to dealing in 90, 180, 270 and 360 degrees. With radians, a quarter of the way around will be pi by 2. Halfway around will be pi radians. 3/4 of the way around will be 3/2 radians, and all the way around will be 2 pi radians. And that'll make some of these answers a bit easy to work out. So the first one, which says for an angle of value 0, determine the value of sine and cosine. Let's give us a bit more space here. So, like in the diagram above, actually I'll just grab a clean one of those. Big up. So we're now on question 1A. So it's saying this angle in here, which they're now calling t, is a value 0. So in this circle, or potato, more like, it's saying that the angle is 0. So it's actually sitting along here at the angle 0. So, like we said before, the value of sine of theta, t rather, sine of t is equivalent to what's the y value. So if the angle's 0 here, it's actually lying along the x-axis. So in terms of the value for y and x, right here, x is equal to 1, because this is a unit circle. So if x is 1, and we know that sine of the angle is equal to x, we can say that sine t is equal to 1. Also, at this point, we know, no, that's not right, is it? X is given by cosine. Cosine of t is equal to 1. The y value is given by sine of the angle, or sine of t. So when we're down here, when the angle is 0, y is going to be 0. So sine of t is going to be equal to 0. Excuse me. Alright, let's do the next one. Similar vein. So question 2. Oh, question 2 is it? Question 1. B. T is equal to 3 pi over 2. So from before, in this unit circle, we said that if you go all the way around, it's 2 pi. So if you go around 3 pi over 2, you've actually gone around 3/4 of the way around. So you're now, in terms of this sort of line being shown around here, you're down here. So that's y and x. Then down here, y is going to be -1 and x is going to be 0. And we know that that's equal to the cosine of the angle, and that's equal to the sine of the angle. Yep. Question 1c, t is equal to -3 pi over 2. Unit circle. So interesting thing now is, even though we start from here, it's actually -3 pi over t. So in my earlier videos I mentioned that if you're going clockwise, which is that way, you are dealing with positive radians, and if you're going that way, you're dealing with negative radians. So this is negative, so you're going counterclockwise. That doesn't look right. Anyway, let's see how this comes out. So we saw before the last one that 3 pi over 2 gets us 3/4 of the way around. So from here, if we go around 3/4 of the way, it'll be round this, round to here. Which isn't right. Okay, question 1c. This time the angle is -3 pi over 2. So I just saw earlier, we tend to sort of not think about how this angle and its sine, what it means. You tend to always think of angles being measured this way around. Well, all it means when it's negative is that you start measuring in the other direction. So you start measuring this way around. So just taking that out. Oops. So starting around the unit circle, and we know that 3 pi over 2 is 3/4 of the way around. But this time we're going negative, we're going clockwise. Yeah, anti-clockwise positive, so going that way is positive, going this way clockwise is negative. Just one of those conventions. So if we go 3/4 of the way around to here, then the values for x and y, here x is going to be 0, y is going to be 1, and we know that at that position that cos of the angle, so cos of t, is 0, and y is given by the sine of the angle, so sine of t is equal to 1. Right. Next one, question 1d, t equals 5 pi over 2. So in this unit circle, because this is positive, it means that we're going to start measuring counterclockwise. And it's 5 pi over 2. So we know that if you go that far around, it's going to be pi over 2. But this time we've got 5 pi over 2. So we're actually going to go around 5 times. So, or 5 quarters I should say. So we're going to go 1, 2, 3, 4, 5 to there. So, okay, badly drawn it like a spiral, but in the unit circle, that would be, that's y and x, that point there, y is 1, x is 0, and we know that sine of the angle is where y is, and cos of the angle is where x is. Scroll down. And question 1e. So t is minus 3 pi. So again, because we're going negative, we're going to be measuring this way around, so we're going to be going clockwise. And it's minus 3 pi. Now when you go half the way around, you've gone around pi radians. So this time we're going around 3 pi. So that means we're going around 3 half times, if that makes sense. So 1, 2, 3. So there. So the x and the y. So over here, y is 0, x is equal to minus 1. We know that's given by the sine of the angle, that's given by the cos of the angle. Okay, question F. T is 9 pi over 2. So this time it's going to be going around the circle a number of times. First thing to check is that it's positive, so we'll be measuring around this way. So this could actually be rewritten as 2 times, let's see, so that's pi over 2, 2 times, so I suppose actually the best way to do it is fraction, so it's actually equivalent to 4 pi, 2 goes into 9 4 times, plus half left over. So right, do some quick math. 1 goes into 2, 8 pi plus pi. Yes, that's correct. Right. Oops. Too much erasing. There we go. Okay. Ugh. So it's equivalent to 4 pi plus pi over 2. Now, the reason I'm writing out in a strange way, 2 times 2 pi plus half a pi, is that we know when we go all the way around a circle, we go around 2 pi radians. Well, this is telling us that we go around 2 times all the way around a circle, plus another pi by 2, which is another quarter. So starting from here, we go around 2 full rotations, so 1, 2, and then we've got the pi by 2, which is another quarter. So we go around to there. So at that point, y is 1, x is 0, and that we also know that the sine of the angle is given by way of wires, and cos of the angle is given by where x is. So just cancel these. Okay, 1g t, the angle is 7 pi over 2. There's our unit circle. So again, remembering that if you go around a quarter, and this obviously positive angle, so we're going around anti-clockwise, that's pi over 2, going around 1/4. So here we're going around 7 quarters. So that's 1, 2, 3, 4, 5, 6, 7. Be down here. Y and x. So down here, x will be 0, y will be -1, which we know is the same thing as cos of t, sine of t. Next one, h, t equals 4 pi, unit circle, y and x. So we know that once around is 2 pi. So going around that way, anti-clockwise because it's positive, round back to here again. So on this unit circle, x is 1 and y is 0. Y equals sine of t, and x equals the cos of t. Next question. Okay, part 2. Oops. This is now from the calculator. So the first thing to be aware of is asking us to solve sine of these next questions. Ask you to use your calculator to do some trigonometric functions, starting with finding the sine of 1.9. Now, as it wisely warns you in the book, it says make sure that you're in radian mode. So just to show you again, in your scratch pad, if you go into doc, scroll down to Gimmon, it's not playing the game. Gibbet, doc, scroll down, there we go. Right, down to settings and status, go right, down to documents and settings, select that, and at the moment the default unit of angle is degrees, so we'll change that to radians because all the numbers in this question are relating to radians, so that's a default. So now if we take this question, so trig, sine already selected, and type in 1.9, enter, there's the first answer, and we might as well keep going. Actually, I might as well just, so that was, trying to be smart here, so that was number 2 part A, so that's A, if I can write small, B is finding the question, sine of 2.3, so, well, no, I'll be lazy, B sine of 2.3, because that one is 0.9. What's the decimal places? Let's go to 2 decimal places. 0.95. So sine of 2.3. 2.3. Enter. Is 0.75. C is the sine of 4.1. So I'm going to make a trig and sine of 4.1. Again, all these are in radians. Is negative 8.8. 82. No, sorry. We're doing 0 there, sorry. Is there a D? Okay, cos of 0.3. It's a little habit that I suppose I get into is I put brackets around the number so that don't get confused, but really you can just write cos 0.3. Okay. Actually, another little funny thing I learned about the calculator is you can actually type out the word cos. C-O-S bracket 0.3 close bracket. So that's 0.96. E is cos of 2.1. Cos of 2.1 minus 0.50 F cos of minus 1.6 cos of minus 1.6 minus 0.03. I'm going to fit this in. G sine of minus 2.1 sine of minus 2.1 minus 0.86, and H is the sine of minus 3.8, which equals, because I've got and sine minus 3.8 is 0.61. Exercise 14B, question 3. Put that over there. Right, so this is asking us to find, for each of the following angles, theta, determine the values of sine theta and cosine theta, or I like to call it the hamburger. Now, probably a useful diagram from the textbook on page 488 is, scroll down a bit, this one, so make it a bit bigger, which will help in solving this. So, picking up pen. So, question 3a, where theta is 27 pi. Excuse me. So we know from how many radians in a full rotation, so if we go all the way around, that's that's 2 pi radians. So here we've got 27 pi. So we actually would have gone around 13 times. That gives us 26 pi plus another pi, which is halfway around. So drawing the unit circle like this, we've already gone around 13 times back to the beginning. So from here going that way, because it's positive, we go anti-clockwise. We've gone around 27 times and then around again, pi radians. That puts us over here. So on the y and x, change colour here. At this point, oops, actually there, y is going to be 0 and x is going to be -1. And we know from sine and cosine that the x is given by the cosine of the angle and sine, oh, sorry, y by the sine of the angle. Yep. Scrolling down. Shall need that one again. I'll just scroll it down. Next one, B. So we've got -5 pi over 2. So the fact that it's a negative means that we're actually going on the unit circle. We're going in a clockwise direction, going this way. And we've got 5 pi over 2. So really, I look at that as 5 lots of half a pi. Now, half a pi radians would be this far around, pi over 2 radians. We'll go around 5 times. So let's go around once, twice, 3 times, 4 times, 5 times, which has actually brought us back. Actually, no, let me just check that, sorry. Let me undo. Starting from here, important thing is starting in the right direction, so we're going this way. 1, 2, 3, 4, 5. Okay, back to here. So on the y and x, here y is -1, x is 0. And we know that sine of the angle gives us y, cos of the angle gives us x. Yep. Okay, so I can squeeze in here. C theta is 27 pi over 2, which, knowing all the way around, is 2 pi. This is like saying 13.5 pi. Just dividing down. Yep. So that means we would have gone around effectively 2 pi into this. So 6 times that. 6, 12, 1.5. Actually, I wrote that. The reason we're writing like this is that 2 pi's all the way around, so saying go around 6 times, so effectively end up back where you started, then go around again 3.5 pi radians, and 3.5 pi radians is, that's half, 1, 1.5, get round to there. So it's down here where y is -1, x is 0. So I'll let myself a little room there. So sine of theta, which is the y, is -1. Cos of theta, which is the x, is 0. Yep. Scrolling down. 50. This time theta is minus 9 pi over 2. Unit circle. Because it's negative, we actually will be going around clockwise, so this way. And it's 9 lots of half a pi. Half a pi is, yeah, this could be a bit long-winded, so let me rewrite that. So that's one there. So let's say it's about 4, well it is exactly 4.5 pi, which I'd look at that as saying it's 2 times 2 pi plus 1.5 pi. So that says go around 2 times, basically you end up back where you started. 2 pi being a full rotation, plus 1.5 pi. And 1.5 pi is going around 3 quarters. So 1, 2, 3, up there, it's y and x. So up there, y is 1, x is 0, and we know that y is given by the sine of theta, x is given by the cos of theta. Cos theta is 0. I have that wrong. Okay, let's do that again. Right, let's try that again. So theta is minus 9 pi over 2, which is minus 4.5 pi. Make sure that's right. Yes. Yep. Which is the same thing as minus 2 times 2 pi. I see my mistake. Plus half a pi. That's what it was. Because 2 times 2 pi plus half a pi is 4.5 pi. All this talk of pi making me hungry. So, but it's negative. So, we're going to go around in a clockwise direction. So, we're going to go around twice. Basically, you go around back where you started, plus another half a pi. Now, half a pi is a quarter of the way around, 2 pi all the way around. So, down here, on the y and x, y is minus 1, x is 0, y is given by sine of the angle, x is given by cos the angle. That's better. Right, on to scrolling down, E. So this time theta is 11 pi over 2, which is 5.5 pi radians. We could also write that as 2 times 2 pi plus 3 over 2 pi. So that's in the unit circle. The rotation, so you go around twice. Now in fact it's positive, which means you go around anti-clockwise. You go around twice, basically back where you started, and then 3 over 2 pi, which is 3 quarters of the way around, 2 pi being all the way around. So in the unit circle down here, y is minus 1, x is 0, y is given by the sine of the angle theta, x given by the cos of the angle theta. So let's see if that's correct. Minus 1 and 0. Okay, on to the next one. On to f. Alright, f is theta is 57 pi. So, okay, this is quite a big one now, but still, it's saying like 2 times, let's see, 256, 25, 28, 2 times 28 pi plus another pi. Now, the reason why I want to do that is you can also write that as 2 times 2 pi, 4 times 7, no, hang on, let's not write it. 2 times 2 pi, 28, yeah, of course. Right, plus a pi. The reason we're writing like that is I want to know how many 2 pi rotations we have in the unit circle. So at the moment, starting here, and it's positive, which means we're going to go around anti-clockwise. So we go around 28 times, back to where we started, and then we go around pi rotation, which that's half a pi. Pi brings us to here. So y is 0, x is minus 1, y is given by sine of the angle, x cos of the angle. And the next one, g theta is 211. Okay, it's getting aggressive now. So that's like saying 2 pi times, what's that, 105 plus 210 plus a pi. Again, I'm trying to factorize it to get how many 2 pi's, because that's really how many times we go around. 105 times, getting back to the same spot on the unit circle. So starting from here, it's positive, so we're going to go around that way. 105 times plus another pi, which is half a rotation in radians. So on the unit circle, we're here. So y is 0, x is minus 1, y is given by sine of the angle, x is given by cos of the angle. That's it, yep. And finally h is theta equals minus 53 pi. So factorizing, getting out to 2 pi. So part of that, minus 2 pi times, what's that, 52, 26 plus, oops, nope, that wouldn't be right, minus another pi. So factorizing by 2 pi to get how many rotations on the unit circle. Starting here, it's negative, so actually going this way. This time we're going clockwise. We go around 26 times, ending up back where we started, and then a further pi rotations, minus pi, so we're rotating in the clockwise direction, and pi being half a rotation, 2 pi being a full rotation, brings us over to here, where here y equals 0, x equals minus 1, y is given by sine of theta, x is given by cos of theta. Check that, yep, good.